Hello everybody and welcome back. I wish I was in person, but this is the best we can do for now. I'd like to start off by saying a little prayer for everybody and wishing you well. I pray for health and healing for you and your family. May God heal all of your sickness and free you from your burdens. He is our healer and our deliverer, and He is well able. Amen. Now, before we get started with the algebra, I would like to tell you that we have lots of work to do before we end the year and to prepare you for next year. I do think it's important that you try to keep up, and I will be available online at some point to assist you. But right now I'm going to do a recording of our main topics, and then we will get together. I hope that you guys are working hard, and you will work hard as we finish up this strange year. But let's go ahead and start with graphing a quadratic equation using a table. Now, I'm going to make a note here as I go through, and you guys can copy it down on your note as well. And then you can share it with me, and I will give you credit for all of your work. All right? So please follow along. All right? Let's see what we can do. Quadratics, super important. We had two major topics, quadratics and rational expressions. So here we go. First of all, I'd like everybody to look at this and see that y equals x squared, or f of x equals x squared. Remember, that's just functional notation. All right. This, I would like to tell you, is actually called the parent function because it's its most basic form. All right. The very basic form. All right. Now, before we graph any of these, anytime you want to graph an equation, you can always just plot points. All right. So that's the first thing we're going to do. Now, you may ask how we came up with these points, and I'll always tell kids that you just randomly select these numbers. Not really randomly, but you always do 0, you do a couple positives, you do a couple negatives. All right? So I started with 0, and we did a couple negatives, and 0, and do a couple positives. So if I plug 0 in, you would know that 0 squared is 0. And if I do 1 squared, that would be 1. And then if I do 2 squared, that would be 4. If I do negative 1 squared, that is also 1. And if I do negative 2 squared, that would also be 4. All right? So as you can see that our graph, all right, has some strange characteristics. All right? We say there's symmetry. All right? Let me talk to you about that. All right, but the first thing we want to do is we want to go ahead and graph these. All right, so if I were to graph this, all right, we'd plot the point 0, 0. Then we'd plot the point 1, 1. Plot the point 2, 4. We'd also plot the point negative 1, 1. Negative 2, 4. Now you should see the outline of the graph, and the outline of the graph looks like this. All right, now that is called a parabola, all right, but it's also called a quadratic, all right. This is a little bit more advanced, and usually when you study Algebra 2, they'll talk to you more about that. Now, what we do is, I mentioned earlier that there's some symmetry here, and the reason why I'm saying there's some symmetry here is because if you notice this line right here, all right, is actually called the axis of symmetry. All right, and that equation in this particular moment is x equals 0. Now, why is it called the axis of symmetry? It's called the axis of symmetry because the distance from the axis of symmetry to a point on the graph is the same on the left side and the right side. Notice here, 2 points. Over here, 2 units also. So it doesn't matter, all right? It'll always be the same distance. And we could just check another point from here to here, and then that's going to be the same as from here to here. All right, so that is called the axis of symmetry. The lowest point on the graph, or the highest point on the graph, all right, is called the vertex. So that point right there is called the vertex, all right, and its point is 0, 0. Now there's a relationship between the vertex and the axis of symmetry. The axis of symmetry is always x equals whatever the x value of the vertex is. So if the vertex was 1, the axis of symmetry would be 1. If the x coordinate of the vertex was -5, the axis of symmetry would be x equals -5. And we'll talk a lot more about that, all right? But that is basically it, all right? That's how you graph or that's what the shape of the quadratic looks like, all right? So I want to make sure everybody understands that. Major topics or major points is the vertex, the axis of symmetry. Another important point is the y-intercept, but the y-intercept in this case is the same as the axis of symmetry. All right. So I want to go ahead with example number 2. All right. Example number 2 is very similar to question number 1, except you see that there's a negative here. All right. Now, what that negative does is that negative, we say, reflects it over the x-axis. But of course, you don't have to know that. That is just something that you should observe as I go to graph this for you. All right. So if I plug 0 in, 0 squared is 0 times -1, because remember, that's an understood 1 in front of there. So that would still be 0. And then if I do 1 squared is 1 times -1 is -1. 2 squared is 4 times -1 is -4. And then -1 squared is 1 times -1 is -1. -2 squared is 4 times -1 is -4. Okay, so now we just go ahead and graph those points. And as you see, when I graph these points, all right, you're going to get 0, 0, 1, -1, 2, -4, -1, -1, -2, -4, and you can see that there is the graph of my parabola. And let's go ahead and draw the axis of symmetry. And this point right here, remember, is the vertex. Now notice this time it's the highest point on the graph, not the lowest. All right, if the graph opens up, it's a minimum. If it opens down, then it's called a maximum. That's what this is. That's the maximum. And the one up here is called a minimum. All right, the vertex is a minimum. Okay, so hopefully I'm doing a pretty good job. Hopefully you understand exactly what I'm saying. Here again, I would want you to write down on the side, axis of symmetry, and we could say the axis of symmetry again is still x equals 0. My vertex is located at 0, 0, and I'm at a maximum. All right, pretty easy. I know you guys aren't going to have trouble with this at all. All right, so now let's go to question number 3. All right, now with question number 3, it should be a little bit different now because it's not in its basic form. We now are just still going to plug in numbers, and we got to go ahead and solve it out. Now, the first thing I want to notice is if I plug 0 in, right, I'm going to go ahead and do the work right over here though. 0 squared minus 2 times 0 is still 0. All right, now I'm going to plug 1 in. 1 squared minus 2 times 1 is 1 minus 2, which is -1. All right, now when you plug 2 in, 2 squared minus 2 times 2, 4 minus 4 is 0. So now I have this 0. Okay, now I plug in -1. -1 squared minus 2 times -1 is 1 plus 2, which is 3. And now when I do -2 squared minus 2 times negative 2, I get 4 plus 4, which is 8. All right. Now, what we have to do is we have to kind of look at the graph and see what the graph is telling us based off the points that we plot. All right. And once we plot those points, all right, you should be able to get a good idea of what the graph looks like. So let's go ahead and do that. All right. So the first thing we're going to do is going to plot 0, 0. Negative 1, 3, negative 2, I'm going to go up to 8, and then 1, negative 1, and then 2, 0. All right. So now this point right down here appears to be the vertex. All right. Now how do I know that? Just because I'm doing a dot to dot, and it goes down, and then it's the low point, and then it comes back up. All right, so that would be the graph of that. All right, so it looks like the vertex is at 1, negative 1, and there's a formula for finding the vertex in the next lesson. I'll be explaining that to you. All right, but the vertex here is 1, negative 1. And now I want to show you the axis symmetry, if that's correct. The axis symmetry, I need to make that smaller. All right, so the axis symmetry would go this way. All right, there's my axis of symmetry. All right, and you notice I'm correct here because if I match this distance here, that distance is the same as there. All right, and kind of if you look up here, that point right there is 2 units away from the axis symmetry, so that appears to be accurate. All right, so we could say our vertex is 1, negative 1. Our axis of symmetry is x equals 1. All right, so again, nothing to it. All right, nothing to it at all, graphing points. All right, in a few minutes I think I can show you how to use your calculator. So you can type this on the calculator and we can look even at our window, all right, or our table on our calculator. All right, let's go ahead and check out number 4 now. All right, kind of similar here. All right, so again, I'm going to start out with 0. So if I let 0, I'm going to go 2 times 0 squared plus 4 times 0. I'm sure everybody knows that's 0. Now I'm going to plug in 1, so it'd be 2 times 1 squared plus 4 times 1 equals, don't forget 1 squared first. 1 squared is 1 times 2 is 2 plus 4 equals 6. All right, now we're going to do 2 times 2 squared plus 4 times 2. 2 squared is 4. 4 times 2 is 8. Plus 8 is 16. So that number's getting kind of big. All right. Now we'll look at negative 1. 2 times negative 1 squared plus 4 times negative 1. So negative 1 squared is 1. 1 times 2 is 2. 2 minus 4 is negative 2. And then if I plug negative 2 in, I get 2 times negative 2 squared plus 4 times negative 2. Negative 2 squared is 4. 4 times 2 is 8. 8 minus 8 is 0. All right. So again, all right, we're just going to plot the points and see what happens. All right. So if I plot the points, I get negative 2, 0. Negative 1, negative 2. 0, 0. 1, 6. And I really don't have space for 16, but I do see the outline of the graph. Look at that. All right, here would be considered the outline of the graph. All right, now it appears like this guy right here is the vertex. So that, again, I want you to remember, is called a minimum. All right, the vertex looks to me like negative 1, negative 2, and the axis of symmetry is, remember, it's always easy. It's just x equals whatever the x value of the vertex is. X equals negative 1. All right, hopefully that was okay for you. All right, again, you got to be careful with the operation because remember, you always have to do what? Square first. All right, don't do 2 times negative 2 and then square. All right, you'll be wrong. Okay? All right, let's check out number 5. All right, number 5 is a little bit different. All right, so let's see. All right, the reason why it's a little bit different, I say, is just because there are 3 terms here. All right, but the substitution is just the same. All right, let's start out with 0. So 0 squared minus 2 times 0 plus 1 equals 0 plus 0 plus 1, which is 1. Now if I plug in 1 squared minus 2 times 1 plus 1 is 1 minus 2 plus 1, which is 0. Then I'm going to plug 2 in. 2 squared minus 2 times 2 plus 1 is 4 minus 4 plus 1, which is also 1. Now I'm going to plug negative 1 in. Negative 1 squared minus 2 times negative 1 plus 1, which would be 1 plus 2 plus 1, which is 4. And then we'll do negative 2 squared minus 2 times negative 2 plus 1, 4 plus 4 plus 1, which is 9. Okay, so now again we can plot these points. All right, so let's start 0, 1, negative 1, 4, negative 2, 9. Then we have 1, 0, and then 2, 1. Okay, look at that. So I think I can see the outline of the graph now. Looks something like this. And then I can bring it back over here. There's the outline of the graph. All right, so we say the vertex, it looks like to me, is 1, 0, which now means the axis of symmetry is x equals, remember it's the x coordinate of the vertex, so it'd be x equals 1. And we could draw that, x equals 1 right here. That's the axis of symmetry. And what else? Oh, it's a minimum. All right, the vertex is a minimum. All right, very simple. Very, very simple. All right, so now let's take a look at number 6. All right, by the way, I just want to say, just for your own information, because this is positive, I know the graph is going to open up. All right, anytime the leading coefficient is positive, it'll open up. Anytime the leading coefficient is positive, it opens up. Anytime the leading coefficient is negative, it's going to open down. All right, so those are just kind of helpful things that help you to determine whether or not you're graphing correctly. All right, so let's take a look at number 6 now. All right, so with question number 6, all right, I want to go to, again, plug 0 in because that's the easiest. So this would be 0 plus 0 minus 2, so it'd be negative 2. Then I want you to plug 1 in. Now remember, negative 1 squared plus 2 times 1 minus 2 would be, got to be careful, you got to do 1 squared is 1 times negative 1. Then it'd be plus 2 minus 2, all right, which is negative 1. Then negative 2 squared plus 2 times 2 minus 2 is negative 4 plus 4 minus 2. So again, that's negative 2. All right. Now let's go over here at negative 1. Negative, parentheses, negative 1 squared plus 2 times negative 1 minus 2. Again, negative 1 minus 2 minus 2, negative 5. All right. Now again, let me just emphasize this. This squared is positive 1. All right. Don't multiply these two together first, or you're going to make a mistake. All right. Now let's go with negative 2. All right. So we go negative 2 squared plus 2 times negative 2 minus 2. So that would be 4, and then the negative. So negative 4 minus 4 minus 2. So that to me looks like negative 10. All right, now we're going to go ahead and graph these. All right, and so now when we graph these, all right, we're going to go with 0, negative 2, negative 1, negative 5, negative 2, negative 10. Then we have 1, negative 1, 2, negative 2. And there you have it. All right, I can now see the outline of the curve. Looks something like this. And opens straight down like that. Again, this now would be considered, the vertex would be considered a maximum. And that point is 1, negative 1. Again, the axis of symmetry goes through the vertex, so it's this line right here. And that is x equals 1. All right, and that's considered, remember, the axis of symmetry. All right. Now, I think what I've done now is I've given you a good start with your graphing quadratics. All right. And the reason why I say that is because now I want you to go to IXL in the algebra section, BB3. All right. I want you to get that to a SMART score of 90. I think it's be easy for you. All right. SMART score of 90, and I'll give you a grade for that. And that'll just help me. And what I'm doing is I'm devising my lesson plans kind of around the IXL. So if you stay with me on the IXL, I mean with my plans that I'm recording, then you should be able to do the IXL rather easily. All right. So what I want you to do now is review your notes. All right. Make sure you understand what I said. Learn how to plot things on a graph like we did, and then go to your IXL. And I think this IXL, all it is just asking you to plot points. All right. But what I want to do now is I want to see how all of this is working, because I will be online at some time asking questions. All right. But I really appreciate you guys. I really am trying to do a good job, because again, you still have to be smart. You still have to know things next year. And I just really want you to be ready. I want you to be the best student you possibly can. All right. So with that being said, I miss seeing you guys. Hope to see you soon. But I have no idea what's going on. And I hope you found this to be productive. All right. Have a good day. God bless.